Good evening, everyone. This is lecture number 9 in ray optics. We are dealing with mirrors, and in the previous class, do you remember what we had done in the previous class?
Yes, sir.
In the previous class, we had discussed points about magnification. We had seen two types of linear magnification: transverse, when the object is placed perpendicular, and longitudinal, when the object is placed along the principal axis. Then we had seen something which is known as aerial magnification or magnification in area, where we had seen that the object will have, it's a two-dimensional object, and we will have a magnified area. Do we recollect this? Do we remember this?
Yes, sir.
Okay, so now in today's class, what we are supposed to do is to see, and these are very important things that you should remember, where the object is and where will the image of the object be formed. So this is a table that you can see on your screen. There are 6 positions that we had to discuss. I told you how we get to these positions. The first position is at infinity, then it is beyond the center of curvature, then it is at the center of curvature. Do you remember all those 6 positions? Yes or no? Do we remember all these 6 positions that we have to study? Position number 1 at infinity, position number 2 between infinity and center of curvature, position number 3 at the center of curvature, between C and F, at F, and between F and P. Do we recollect these? Yes or
Yes.
no? Do we remember this, bacha?
Yes, sir.
Okay. And today what we are going to do is we are going to see different positions and where the image is going to be formed, and you have to remember this because a question can come on this topic straight away, and you must memorize all these positions. They must be in your memory always, and you cannot forget them. The first position that we are talking about, I think we had already discussed this, but I'll again go back to it. The first position that we had talked about is the position where the object is at infinity. And I told you, when the object is at infinity, rays of light will be coming parallel. Yes or no? No, yes.
Yes, sir.
Then the image is always formed at the focus. The image is highly diminished, it is real, and it is inverted. Have you noted this down? Have you drawn this table? Are you noting it down? Yes or no?
No, sir.
No, sir.
Why are you not noting it down?
Give me time, sir. I'll note it now.
You were not present in the last class, beta?
No, sir. I was absent.
What about the others?
He did not note it, sir.
Bad. That is bad. Okay. Not a problem.
Just give me 2 minutes, sir. I'll write.
What about the other students? Have you noted it down?
No, sir. Please give us also 2 minutes of time.
Okay. Not a issue. Please note it down, beta, because you will have to remember these things. These are important things, and you will have to note them down, because you may not be remembering them without noting them down. So it is better that you note them down. I am waiting for you to note. Okay, I'll give you time. Let me know once you are done, okay?
Okay, sir.
Sir, 1 minute.
So if point number 1 is done, then we can move on. You just have to note down point number 1. Once I discuss these points, Then you will note down point by point, not all of them together. All of them together is not going to serve any purpose. I want you to understand each and every point, and then note them down. So right now you just need to note down point number one, where the object is. The object is at infinity and the image is formed at the focus. Shall I move ahead?
Yes, sir.
Noted? So then this is the diagram that is showing you the same position. You may not note down this diagram. This diagram is just for you to understand how this image is formed. As you can see, rays of light are coming from infinity and the image is formed at the focus. There is a slight difference between what you have written and what is here. What you have written is rays of light which are parallel. So if the rays of light had been parallel to the principal axis like this, if the rays of light had been parallel to the principal axis like this, then the image would have formed exactly at the focus. So that is what you have written. I hope you understand this. The thing that I have drawn is what you have written. In this diagram that is shown, they have shown parallel rays, but they have not shown rays parallel to principal axis. Do we understand this? The difference between the two diagrams is when the rays are parallel to the principal axis, I get image exactly at the focus. If the rays are not parallel to principal axis, I get the image at the focus, but it is not a point image. You will have some height of the image. Do we understand this?
Yes, sir.
This is point number one. You may not have to draw the diagram. No one is going to ask you to draw the diagram. This is just for your understanding about what the position is and how is the image formed. The important point that you have to remember is very simple. The important point is that when the object is placed at infinity, image is formed at the focus. The image is real, the image is inverted, and it is highly diminished. Have you written this? Yes or no?
Yes, sir.
Point number one, position number one, that will take us to position number two. And what is the position number two? The object is placed more than 2f. That means object is placed beyond the center of curvature, between infinity and center of curvature. Whatever you say, it means the same thing. Now when the object is placed beyond center of curvature, away from the center of curvature, you have to understand where is the image formed. Every point is very important. Image is formed between f and 2f. That means image is between c and f. The magnification is less than 1. That means image will be smaller as compared to the object. Image would be smaller. Image would be real and image would be inverted. Do we understand this? The ray diagram I will show after this so that you have an image of what is happening there. You may not draw the ray diagram, but you will have to remember whatever I have highlighted in green. You can write everything in short. Whatever I have highlighted in green, even if you write that much, you have to understand it. You may not write it in English, you may write it in your own language, whatever language you are comfortable with. Have you noted down point number two, my dear friends?
Yes,
Position
sir.
number two. Now I will show you the diagram of position number 2, and the diagram looks like this. Position number 2 diagram looks like this. Object is placed between infinity and C. You can see, my dear friends, C is here. Object is beyond C, and as you can see, the image the image is formed between C and F. Image is formed between C and F. You can see that this image you can see that this image is smaller than the object. It is real and it is inverted. Do we all see this? Yes or no? No, yes.
Yes, sir.
So this is what you need to remember. You may not draw the diagram, but this is just to show where is the image formed. This is position number 2. Object is beyond the center of curvature, or you can say between C and infinity. Do we understand this? Can we move on to the third one? Yes or no? No or yes?
Yes, sir.
Yes, sir.
But first of all, you have to tell me, my dear friends, what would be the third position like? Where would the third position come? Remembering the third position will help you in understanding what is going to happen next. Where will be the third position be, my dear friends?
At center of curvature.
Yes, that is correct. The third position is definitely center of curvature, and no prizes for guessing this. The object will be placed here like this. The object, pink one now, object is placed at the center of curvature. The value of u is 2f. It would be minus 2f, sign convention wise. The image will also be formed at the same position. This is the only position where the image and the object coincide. So this is a very, very important case, because whenever you have a question where they say object and image are formed at the same position, the answer is center of curvature. Do we understand this?
Yes, sir.
The magnification is equal to 1. That means object and image are of the same size, my dear friends. Same position, same size. The image is real and it is inverted, so you will have image like this. Position number 3, dear friends. Object is placed at the center of curvature. Image is formed at the center of curvature. Real, inverted, and the same size as the object. Do we understand this? Yes or no? No or yes?
Yes, sir.
You just need to note down what I've highlighted. The important point is the highlighted part. English, Hindi, Tamil, Telugu, Kannada, doesn't matter. Let me know once you are done. Shall I move on?
Yes, sir.
If you have noted this down, this is a diagram that you must remember. As you can see here very clearly, the object is placed at the center of curvature. HO is the height of the object. The image is also formed at the same point. HI is the height of image. Same position, inverted, same size. This is a very, very important result. Do we understand this? Yes or no? No or yes?
Yes, sir.
You may not Again, I repeat myself. I keep on repeating myself. You may not have to draw the ray diagram, but you need to understand the position and where is the image formed. Ray diagram is not important at this point. Important is that you understand position number 3, a very important position, I must say, because this is the position where object and image coincide and they are of the same size. Can you move on to the next point? Point number 4.
Yes, sir.
Where is point number 4 going to be, my dear friends?
Between center of curvature and focus.
Between center of curvature and focus. That is your answer, and that is exactly correct. I will paint it by blue. The object is placed between F and 2F, focus and center of curvature. Image is formed beyond center of curvature, beyond center of curvature. The magnification is greater than 1. The image now is bigger compared to the object. Image still remains real. It is still inverted. Do you see, my dear friends, any similarity between point number 2, position number 2 and position number 4? Do you see any similarity or any difference? Any relation? Let me put it that way. Any relation between position 2 and position 4? This will help you in understanding them and remembering them. Yes. Between position 2 and position 4, do you see any similarity, any relation, anything that you can draw? Do you see any relation? Yes or no? No, yes.
Yes, sir.
What? You have written it down in your notebooks as well.
Sir,
Yes. This is how you will remember things better.
sir, can I try?
Yes, try. See, no answers are right or no answers are wrong. Trials are important. Yes.
The position in second one is between infinity and center of curvature, but it in fourth one it is between center of curvature and focus.
Yes. So, what is the relation that you see? You only said half of the thing. You have missed the other half. Position number 2 and position number 4, from where I look, are opposite of each other. In position number 2, object is placed beyond center of curvature. Image is between C and F. You look at point 4. Object is between C and F. So basically what has happened, beta, is these two positions have interchanged. In case number 2, where the image was, now we have kept the object here. And similarly, in case number 2, where the object was, we are getting the image there. So these 2 points have interchanged. Do you see that? Do you see this?
Yes, sir.
Yes, sir.
So in a way, they are opposite of each other. When you place the object beyond center of curvature, image is between C and F. When you place the object between C and F, the image is beyond center of curvature. Do we understand this? Yes or no? No, yes.
Yes, sir.
Yes, sir.
And therefore, the image distance is more. And therefore, my dear friends, the magnification is greater than 1. As you can see, from here to here, the magnification is increasing. First case, magnification was literally 0. Then when the object becomes closer, magnification increases. At the center of curvature, magnification becomes 1. And I am getting more close. Magnification is getting bigger and bigger. Do we understand this? Yes or no? No or yes?
Yes, sir.
Yes,
So from
sir.
where I see, position number 2 and position number 4 are opposite of each other in that way. And that is how I remember them. I hope you have noted it down. Yes or no? No, yes.
Yes,
Yes,
sir.
sir.
Here comes the diagram to verify what we are saying. As you can see, here the object is between C and F. Do you see it, beta? Between C and F, you have the object. Here, between C and F, oh, the point number 3 is not visible. Let me try to show both of them together. If I can or I can't, it will be too clumsy. Let us forget about this. So here object is placed between C and F, and you have the image coming beyond F. And the image is now bigger than the object. You don't have to draw the diagram. Diagram is just for your understanding, my dear friends. Diagram is just for your understanding, my dear friends. Don't have to draw it. You just need to understand. Remember these positions, because that is what is going to matter in the examination hall. No one is going to ask you the ray diagram, bacha. Ray diagrams are not asked in the NEET exam. So you don't have to worry about the ray diagram. Can you move on to the next position, bacha?
Yes, sir.
What is the next position? Tell me that first.
At focus.
At focus. Point number 5. That is at focus. Yes or no? When the object is at the focus, let me again start with the yellow thing. When the object is at the focus, the image is at infinity. Image is very large, highly magnified. Image is still real and it is still inverted. Now, do you see some similarity between this one and this one? 1 and 5, 5 and 1.
Yes, sir.
What? Similarity or relation or whatever you call it. Yes, what is the relation? What relation you can infer?
They are opposite of each other.
They are sort of opposite of each other. In point number 1, object is at infinity, so image is at the focus. Point number 4, no, point number 5, object is at the focus and therefore image is at infinity. And you can also see their magnification are reversed. In case number 1, magnification was literally 0. Now the magnification is literally infinite. Do we understand this, or this has gone about at saying bye bye? I'm going, sir. Bye bye. Do we understand this?
Yes, sir.
Have
Yes,
we
sir.
noted it down? Have we noted it down? This is how you remember things. This is how I remember things in my life. It's very hard for me to remember things, but I found out some similarities, some relations, and that makes life a bit easy for me. Have you noted down point number 5?
Yes, sir.
Shall I move on to the next point, beta?
Yes, sir.
Not the next point. I am afraid I have to show you the diagram, and here is the diagram, and you can see this diagram is the exact opposite of diagram number 1. Yes or no? No or yes? This diagram is exactly opposite to the diagram that we had drawn in case number 1. So if you remember case number 1, my dear friends, you must be able to recollect case number 5. If you remember case number 2, you should be able to recollect. You should be able to recollect case number 2. Do we understand this? 2 and 4 are similar.
Yes, sir.
Okay. That was position number 5. The diagram is not important. What is important is you understand what we are doing. Yes or no? No or yes? Just give me a minute. My screen seem to have stuck. Just give me a minute. Just give me a minute, beta. So, I think we have discussed point number 5. Yes or no? We remember point number 5? Opposite of point number 1. What remains is the next and the last point in this is point number 6. Where is this point number 6, my dear friends?
Between pole and focus.
This is again a very important point which is going to tell us a lot of things. We'll memorize everything, don't worry. Point number 6. The green one is between, the object is placed between pole and focus. Pole and focus. Now, in this case, up till now, the image was real. Now, this is the only case where the image is
Virtual.
virtual. So it is not going to come on this side, same side. It is going to come on the other side, and it will come on the other side in such a way that the distance of the image, will be more than the distance of the object, and therefore you will always get a magnified image of the object. Do we understand this?
Yes, sir.
Magnified image of the object. This is only one position where the image is going to be virtual. Have you noted this down, bacha?
Yes, sir.
Please note it
Yes,
down.
sir.
And then I will show you the diagram of this gentleman. Point number 6. This is the point that we are concerned about. Point number 6, and it comes on your screen right away. Object placed between F and P. This is F, this is P, and object is here. And as you can see, my dear friends, image is on the other side, and the image is magnified. These are the 6 positions of image formed by a concave mirror. Remember, for concave mirror, we have 6 positions, but for a convex mirror, we will only have 2 positions. Have we noted it down, beta? Everyone, the 6 positions of the object and the 6 positions of the image, we will, we will, we will note down some important points here. But first, I want you to be comfortable with what we have written up till now. Have we noted it down, bacha?
Yes, sir.
Okay, so what I'm going to show you now is a smaller version of the same table. I've shown you the bigger table. This is the smaller version of the same table. It only has those things in very, very short form that we require. It tells us where the object is, where is the image form, and what about the magnification of the image. This is all that you need to remember in short, very crisp manner. Don't have to remember the entire big table. This small table is going to do the purpose. I could have shown this table before, but I wanted to you elaborate first so that you understand things first, and then you can just note them down. Note them down in the simplest possible form. Do we understand this? Yes or no? No or yes?
Yes, sir.
Okay. So if you want, my dear friends, you can note down this one as well. You can note down this what should I say, this thing as well, this table as well. If you want, you can note it down. The same table, but nothing has changed here. The only thing is it's just in a very short form. And remember, you'll have to remember this. Have you noted it down? Shall I move forward ahead in life?
Done, sir.
Completed, sir.
Okay. That takes us to the summary of this entire thing, and I will summarize all these important points about concave mirrors. And you will have to remember them. This is a quick recap of what we have done. Point number one: for real objects, for real objects, a concave mirror can form what type of image? Let me put it in the form of a question and answer. For a real object, a concave mirror can form what type of images? The answer you already know. You just have to give it to me in short. What type of image can a concave mirror form for real objects? You already seen that. No answers? I wonder then what we have written. What type of image can a concave mirror form for a real object? It can form
Real
only real.
and inverted.
Real and virtuals.
Real is always inverted, beta. Yes, it can form real as well as virtual image. Do we understand this? Yes or no? No or yes?
Yes, sir.
Yes, sir.
Simple question. I don't ask complicated questions. Now, remember this. Now, if the image is real, the magnification can be less than 1. The magnification can be equal to 1 and the magnification can be greater than 1. Yes or no? No or yes?
Yes, sir.
When is the magnification? When is the magnification greater than 1? Real image and magnification greater than 1. When does that happen? Tell me.
When it is at infinity.
Great. Sorry. The first one is less than 1. Less than 1, not greater than. Less than 1. Less than 1. Where does that happen? The object distance is greater than 2f. Do we understand this? Yes or no?
Yes, sir.
Yes, sir.
Everything in short, in the form of question and answer. Where is the magnification equal to 1? Real image and magnification equal to 1.
At center of curvature.
So the value of u is 2f. I am not using sign convention. It will be minus 2f actually. Where is the magnification, my dear friends? Greater than 1.
Between center of curvature and focus.
So 2f is greater than u is greater than f. Do we understand this? Yes or no?
Yes, sir.
The object lies between f and 2f. But in case of, my dear, virtual image for a real object, there is only one condition, one case. This virtual image for this real object will always be magnified. Magnification m would be greater than 1. Yes or no? Do we understand this?
Yes, sir.
And where is this virtual image form? What is the position of the object?
Between pole and focus.
Yes, 0 is less than equal to u is less than equal to f is less than equal to f. Do you understand this?
Yes, sir.
Yes, sir.
A concave mirror can form both real and virtual image of a real object. Real image can be diminished, it can be equal, or it can be magnified, but the virtual image is always magnified. Do we understand this?
Yes, sir.
Now, the second type of object, we have not drawn the image. When the turn comes, we will draw. For virtual object, what it can do, and this is a very important point that may come as a direct question in your exam. For a virtual object, real object, it can do all the things. It can form real image, it can form virtual image. What about the virtual object? What do you think if the object is virtual? What type of image can a concave mirror form if the object is virtual? Yes, tell me, my dear friends. No idea? For virtual object, it can only form real images. For a virtual object, a concave mirror can only form real images. A concave mirror, and that is an important point, concave mirror cannot form what? One case it cannot do. A concave mirror cannot form what? It cannot form. It cannot form virtual image of what? A concave mirror cannot form virtual image of virtual object. Can you remember this?
Yes, sir.
Yes,
Well,
sir.
if you can, well done. A concave mirror, for a real object, it can do everything, but for a virtual object, it can only form real image. It cannot form a virtual image. Do we understand this?
Yes, sir.
So this encompasses everything that we have studied about concave mirrors. I'll wait for a second, 1 minute, for you to ask any doubt if you have for concave mirrors. I'll give you a minute so that you can ask me any doubt that you have. Please ask any doubt if you have about concave mirror, else we will move on to the next one, my dear friends. We understand this?
Yes, sir.
Shall I move on? Life has to go on? Yes or no? No or yes?
Yes, sir.
Yes, sir.
So we move on to the next thing, and the next thing is image formation by a convex mirror. It is very simple because we only have to deal with two positions. It's very simple. Position number one, my dear friend, is the object is at infinity. My favorite, infinity. The distance of the object is infinity. Image is formed at the focus, we all know this. Magnification is less than 1, it is very diminished. Oh, image is virtual and it is erect. So for this position, this convex mirror is going to give you a virtual image. Concave mirror was giving you real image, my dear friends. This gentleman is going to give you virtual image, and that is why this is used in your rear car mirrors, convex mirrors. It will give you virtual image that is on the other side. If it was on the same side, you will not be able to see the coming vehicle. Do we understand this? Yes or no? No, yes.
Yes, sir.
Have you noted it down, my dear friends?
Yes, sir.
And this is the example of the image being formed virtually behind the mirror, and this is the diagram that I was talking about. Do we understand this? As you can see, my dear friends, these are the parallel rays of light. They are trying to move towards the focus. They cannot go there. After reflection, they would be reflected like this. This one will be reflected in the same direction because it is falling perpendicularly. Anyways, they are not actually meeting. They will meet when you extend them backwards, and therefore you have a virtual image. Do we understand this? Yes or no? No, yes.
Yes, sir.
Again, I keep on insisting that you don't have to draw the diagram. Diagram is for your understanding only and only. It is not going to be asked ever. Just have to understand the diagram, understand the position and the diagram, and that's it, my dear friends. Nothing else is required. That is position number 1. Object is at infinity. Image is formed virtually at the focus. Can I move on to the next point?
Yes, sir.
And the next point is here. Now, you can place the object anywhere. Anywhere you can place the object. Let us say I put it here. Anywhere you place the object now. Anywhere between infinity and pole. Remember the position. The position of the image is between pole and focus. Diminished, virtual and erect image would be formed. If you place the object anywhere else, the image is always formed between the pole and the focus. It is diminished and it is virtual. Since it is virtual, it has to be an erect image. Do you understand this?
Yes, sir.
Then a quick glance at the diagram will help us understand how this image is formed. This, my dear friends, is your object. You have drawn the ray diagram. Rays cannot actually meet because this is a diverging lens. It diverges. You can see this image here, not actually meeting. It's a virtual image and it is between the pole and the focus. That is all that is there in this topic that you must understand and not forget. Do we understand this? Yes or no?
Yes, sir.
Have you noted it down?
Yes, sir.
Okay. We have written some important points about concave mirror. Now is the turn of important points about convex mirrors. Important point about convex mirrors. Now remember, in concave mirrors, for real object, it was able to make real as well as virtual image. Now I ask you, and you know the answer. For real objects, in case of a convex mirror, what type of image can I get? The answer you already know.
Virtual.
It is always virtual. Yes or no? No, yes. Do we understand this?
Yes, sir.
And it is always smaller size, bigger size, which size? It is always diminished. Do we understand this? It has gone above our heads. Sir,
Yes.
निकल गया. Bye, 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 bye. Please don't worry. It has gone above our heads. Do we understand this? Yes or no?
Yes, sir.
Paka?
Yes, sir.
That is your important point number one. For a real object, convex mirror can only make a virtual image, my dear friends. And it will always be diminished. Now let us bring our attention to the next type of object which we have not drawn the diagrams, remember. For virtual objects, but now I am asking you to make inferences. For virtual object and convex mirror, what do you think? What type of image can it form? If the object is virtual, please tell me, what do you think would happen if the
What
object is virtual? What type of image can a convex mirror form? Just use common sense. See what is happening. Yes. What type of image can a convex mirror form for a virtual object?
virtual image, sir.
It can form virtual image. Anything else? See, if you take inferences correctly, and I'm going to show you for a concave mirror what was happening. And I want you to take inference from here and then tell me for virtual object what can a convex mirror do? And my dear friends, what is the answer? It can form both
Virtual.
real and virtual images. For a virtual object, my dear friend,
Sir,
a convex mirror can form both real and virtual images. Yes,
sir, how can it form real image, sir?
it forms. No, not a matter of how it forms, it forms. And I'll show it to you, don't worry. Not by the means of a ray diagram. I will show it to you by a problem, don't worry. I will show
Okay,
how
sir.
it can form.
Okay, sir.
I will show it to you how it can form, don't worry. But you must understand that it can form both real as well as virtual images. Trust me on that. Okay, there is one thing that it cannot do. And now I ask you that instead of like this, there is one thing it cannot do. And what it cannot do? The most important point. It cannot form convex mirror can't form what? Yes. Again, just apply a bit of inferences.
It cannot form real image for real object.
Yes, my dear friends. Now we are talking. It cannot form real image of real object. If you understand this term, I must congratulate you that you have done a really good thing. A convex mirror cannot form real image of a real object. It can form a virtual image of a real object. For a virtual object, it can do both real as well as virtual. It cannot do real for real. It cannot do real for real. If you compare it with a concave, compare it with a concave. For real, it can do real and virtual. For virtual, it can do real. It cannot do virtual for virtual. Do we understand this?
Yes, sir.
Yes, sir.
It has gone above our head saying bye bye. I'm going, sir. Please don't worry. Don't need to worry, sir. I'm going. Do we understand this? Yes or no?
Yes, sir.
Yes, sir.
Okay. Then what
Pakka, sir.
I'll do is, since it's been a long time, we had gone through this formulae. I'll just write the formulae once again so that we can go about solving problems. Formulae that we have seen up till now. Remember, all the formulas have to be used with what? Proper sign convention. Do we remember it? Yes or no?
Yes, sir.
The first formula is F is equal to R by 2. The mirror formula is 1 by U plus 1 by V is equal to 1 by F, which is nothing but equal to 2 by R, whatever way you look at it. 3. Lateral magnification. No, lateral magnification or transverse magnification. This is height of the image divided by height of the object. This is equal to minus V by U. And we had seen two other variations of the same formula. F upon F minus U, or it will be equal to F minus V by F. Do we remember this? Yes or no?
Yes, sir.
You have to remember it, otherwise you will end up in trouble, my dear friends. Formula number 4, longitudinal magnification. You would hardly need it, but you can remember it, minus of V2 minus V1 or divided by U2 minus U1 for small objects.
Sir, in third formula, it is like F minus V divided by F.
Oh, sorry. Yes, sorry. Genuine mistake. For smaller object, it is minus dv by du. That means you are paying attention to what I'm writing, and that is great, my dear friends. And that will be equal to v by u ka whole square, and that is nothing but m ka square. The fifth formula that we have seen is ms, superficial magnification, and that was simply m square. That was nothing but area of the image divided by area of the object. Remember, for concave mirror, focal length is negative. For convex mirror, focal length is positive. For real objects, u is negative. For virtual objects, u is positive. If the image is real, magnification is negative. If the image is virtual, magnification is positive. Do we all understand and remember this? Yes or no? No or yes?
Yes, sir.
Now comes, my dear friends, the day where we solve the first problem. And remember, problems are very simple. If you just remember this formula, you can solve any problem in a flash. When I say in a flash, that means very, very quickly. Are you ready to solve the first problem? Remember, the problems are very simple. Are we ready?
Yes, sir.
The first
Yes, sir.
problem comes on your screen right away. A convex mirror of focal length f forms an image which is 1 by n times the object. The distance of the object from the mirror is, and you have different options. Let's see if you can solve this one. This may not be the ideal, simplest question that I have given it to you. But I thought that if you can do this, it would be a good thing if you can do this. You can't. I will have no objections because somewhat it requires everything that we have learned so far. Do you think you will be able to do this, or should I give you a simpler one? So you have to find the distance of the object from the mirror. That means you have to calculate u. Yes or no? The focal length of the mirror is given. The focal length of the mirror is given as f. The image is 1 by n times the object. That means what is given to you? Image is 1 by n times the object. That means what is given to you? Which value is given to you? F is the focus. You have to find out u. What is given to you?
Magnification.
Magnification is given to you. The value of magnification is 1 by n. But the question is, will it be plus 1 by n or will it be minus 1 by n? That is not given. It is not said. It is not given. Whether it is forming real image or virtual image, how will I find out whether the magnification is positive or negative? The question, the answer is in the question itself. Is the magnification positive or negative? Who can tell me? Is the magnification positive or negative? And the answer for this is magnification has to be positive. Magnification has to be positive. Why is the magnification positive? And that was the only thing that you had to understand. Remember, it's a oops. Remember, it's a convex mirror that is given to you. A convex mirror can only form what? For a real object, it can only form. For a real object, it can only form virtual image.
Virtual image.
Yes, and for a virtual image, magnification is positive. So
Positive.
this what you had to understand. Now the question is very simple, my dear friends. Solution is very simple. Magnification is given as plus 1 by n, my dear friends. Focal length f. Will it be positive or will it be negative? It would be positive because this is a convex lens. You just have to calculate the value of u. M is given, F is given. You have to calculate the value of u. You just have to put the straightforward formula. Which one? You just have to put the straightforward formula. Which one? Which one? This one. If you can do it quickly, do you understand?
Yes, sir.
You just have
Yes,
to
sir.
put this formula and you will get your answer very, 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 very quickly. So what you got to do is put the formula, get your answer. So plus, oops, wrong color. So plus 1 by n will be equal to plus f upon plus f minus u. Why writing plus f here? So that you understand. What do you understand? What do you understand from these pluses? You understand that every formula has to be used with sign convention. From here, you should be able to get the value of u. Can you tell me what is the value of u you are getting? Can you tell me what is the value of u you are getting?
Sir, A option.
A option is not correct. A option, yes. A option is correct. You will get the value of A us minus of n minus 1f. Is that correct? You will get the value of u like this. This why is this minus sign coming? This minus sign is coming because the object is real and your answer will always come with the proper sign convention. Do we understand this? The answer that you get will always come with a proper sign convention. You just have to solve this equation. Can you solve this equation or should I tell you how to solve this? It's very simple. Cross multiplication. You take this here, you take this here. Yes or no? So on the left hand side, you will have f minus u, and on the right hand side, you will have nf. So from there, you can get the value of u minus u will be equal to n minus 1 times f. So u would be equal to minus of n minus 1 f. Yes or no? No, yes. Do we understand this?
Yes, sir.
How many of you got the answer? Please tell me. Abhiram, well done. What about the others? Did you get the answer?
Yes, sir.
So, in the next class, we will go ahead and solve more problems. I have given you 1 day, 2 days to go through the entire thing that we have done so that when we come back on Monday is your next class, we should be able to crack the problems straight away. So we will be doing problems starting Monday. We will be taking questions from the previous year exams as well and see what types of questions come and how many of you and how many of them you can do very, very easily. So with that, I finish today's class. I hope to see you in the next class. Take care. Have a nice day. If you have any doubts, please come up.